Let me draw over here. Okay, on Monday, we started on this example. Okay, let me quickly recap to see to know where we are. Okay, let me quickly recap. Okay, so now we draw our transformation. So we know that this is our x, y, and z, and we are going to analyze them from planes. Okay, so I remember the first plane that we are going to look at is I constructed. This is our x, and this is our y. This is rotation about z. Okay. So from here, I'm going to sketch in 2D now. Okay, I'm going to sketch this in 2D. So we have four, 6. Okay, I'm going to make it thicker a bit because I need to draw a lot of stuff. And then we have 10, 2, 4, 2, 4, 6, 8, 10. Okay. And then I'm going to draw our centroid. Okay. So the next thing, like what I said, construct the centroid that is related to the what? Where the point of interest is, which is your element. Then we draw our elements. Okay, we construct elements. This is our element K. And this is our element H. Okay. So now we put in our forces over here. We have our 50 pounds. Over here, we have our 150 pounds, right? Then we have a load applied in this direction at 150 pounds. And then we have a force coming in at 200 pounds. Okay? Now, a student came and told me, Eugene, the point of failure, can anyone tell me where failure will occur? Right? Failure will occur at this end. He's absolutely right. Okay, but for this question, we want to analyze what is happening on element H and what is happening on element K. In practical engineering, if you're going to analyze this structure, the failure will be exactly down here. Okay, this is an example to teach you the fundamentals, not necessarily what you will do in engineering world when you analyze a structure like this. That is the difference between education here and hopefully you get a core. Okay, right?
Eugene,
Yes.
would you be able to show that online? Because we couldn't see what you
Sorry.
were referring to.
I forgot to turn on the camera also. Thousands of apologies. Okay, so where failure will occur is failure will occur. Now, my pen don't work. Welcome to, got too excited. Failure will occur down here. Okay. Right, so the next thing that I told you, I remind you is do not analyze the dots and crosses, yes? So the next rule I make is do not analyze the dots and crosses. Okay, so now let's see now. Okay, so we know that there's an axial load. Okay, we know there's an axial load in x direction going at 150 pounds. Okay, why is that? Because the 150 pounds that I'm going to highlight now, right, will generate an axial load over here, which I'm going to draw in a different color, okay, on the centroid at 150 pounds. Not only that, it has a what? It has a perpendicular distance to the centroid. Okay? And this perpendicular distance is 10 inches. So the moment about Z is equal to 150 multiplied by 10 is going to be 1,500 pound inch. And the rate that is moving, okay, the moment will generate this direction. So from here, we can write this down, okay? Let's look at Px. Px is going to be positive, so you can write over here element H and element K are going to be what? Tensile. Okay? Well, moment about Z, if we look at element H, right? You look at element H is going to be in what? It's equal to tensile. And element K is equal to 0 because it's on the what? Centroid. Okay, this is because that it is on the centroid. Okay. Now, we have just applied eccentric loading. Okay, we have just applied eccentric loading. What do I mean? How we get the moment, right, is we multiply by what? 10 to the what? You see that? We did not do this. We did not say, okay, element H, our perpendicular distance is here to here. Right? We did not do this. Or on element K, our perpendicular distance is from here to here. No, we did not do that. Yeah, we did. I mean, element K is fine, but element H, this is basically wrong. Okay, that's why I want to highlight when is it to the centroid. Okay, so I'll write this rule. Okay, I'll write this rule. Okay, I'll write this rule. Okay, this is important. This is important. Now, by the way, I did not do this. I want positive to go in the right direction, and I want positive to go clockwise. Okay, this is up for you to decide. Okay, right? If I call this positive, means when over here it's positive, the direction is correct, and towards the right it's also positive, means the direction is correct. If it's negative, it just switch your direction. Right. So an important thing to know is this. Okay, when the applied force is parallel to the centroid, the perpendicular distance is the distance between the applied force to the centroid. Okay, that's important. Okay, so we have nothing else to analyze. Remember, what did I tell you? Analyze the arrows, okay? Do not analyze the dots and crosses. When there's nothing else to analyze, let's look at another view, okay? So the next view that I'm going to generate is I'm going to have a view that is going, we're going to view in the plan view, okay? We are going to view on the XZ plane, okay? So I'm going to copy my image again. I do apologize, jumping around. Okay. So now we are going to view in the, oh, someone online has question. Hold on. Oh, okay. The question was answered. So now we are going to look at the XZ plane. So we're going to sketch the XZ plane. Okay, and then using right hand rule, this is rotation by Y. Okay, so we're going to view this now. So it's going to look like this. For okay, 4, 4, 6. And then there's a circle down here. Okay. Then again, construct your centroid that's related to the elements. Okay. And then you draw your elements. So now we are looking at the plan view. Okay. We are looking at a plan view. So this is our element H. And then this is our element K. Okay. And then we start to sketch our applied force. So you have 200 pounds. You have 50 pounds. Okay. You have you have over here 150 pounds. And then you have 150 pounds over here. Okay. So this is how our structure will look like. Okay, so let me make this small so you can refer it to. Let me put this up here. Okay, now what is very interesting now, as you can look at the plan view now, you realize that the 150, you can see now, right? Is in fact generating a what? An axial load, yes or no? But we already done that already. We already translate that in the what? Previous view, okay? Now, the rest is just your 150, 50, and 200, okay? So we know we are going to have a shear at element A, okay? Let's do something simple first. I'm going to call anything that is positive coming downwards, okay? So I'm going to do forces in the Z direction, okay? So this will be equal to 150 plus by 50 minus by 200, okay? So we are lucky. So this is equal to 0. So our shear force in the Z direction is equal to 0. Okay, there's no shear force. Okay, now the next one is, how about the moment now? Okay, so the moment now, so I'm going to take moment, any moment that's anti-clockwise, moment about Z, okay, will be equal to any moment now. hold on. Over here, the moment in Z is taken at point H or point Y or element K. Okay, either one. Okay. So what is the perpendicular distance now? Okay. So we know that the 150 is going to be multiplied by 4 and it's positive. The 50 is also going to be positive to multiply by 10. If you guys can see the geometry up here, right? This is 4 and 6. Okay, so plus 150 multiplied by 10, and the 200 is going anti-clockwise, and this is 10. Sorry, it's going clockwise. So this is equal to 150 multiplied by 4 plus by 150 multiplied by 10 minus by 200 multiplied by 10. So it's equal to 100. Let me do it again. 150 multiplied by 4